Okay, so we're going to look at an example. The example says, find the number of ways to create a committee of 2 employees with 1 male and 1 female. And the employees that we have are Toby, Bob, Jill, Sarah, and Felicia. Okay, so because we need 2 employees, I drew out 2 lines. On the left, I put down male, and on the right is female. So for the males, we know that we have 2 options to choose from. It's either Toby or Bob. And then for females, we know that we have 3 options, which is Jill, Sarah, or Felicia. So for the male, since we have 2 and we're choosing 1, you're going to write down 2, choose 1. And for the females, since there's 3 options and you're choosing 1, it's going to be 3, choose 1. So we can use the multiplication rule to figure out the total number of ways to create a committee with 1 male and 1 female. So notice that I have the product sign from I equals 1 to 2, ni, which equals n1 times n2. We know that n1 is 2, choose 1, and n2 is 3, choose 1. So when you multiply that out, remember to plug it into the combination formula. So you have 2 factorial over 1 factorial times 2 minus 1 factorial. And then you're going to multiply that whole thing by 3 factorial over 1 factorial times 3 minus 1 factorial. Okay, and then you're going to simplify and you're going to get 6. So there's 6 ways to pick a committee with 1 male and 1 female. In this next example, we're going to look at how to find the probability of getting 3 tails and 4 coin flips. So we want the probability of 3 tails and 4 flips. And the way that we get that is our numerator is going to be the number of ways to get 3 tails and 4 flips divided by the number of ways to get 4 flips. So I've indicated the numerator with a yellow arrow and the denominator is noted with an orange arrow. Okay, so looking at the numerator, it says the number of ways to get 3 tails and 4 flips. So that means n equals 4 flips and k equals 3 tails. So you're going to have 4, choose 3. And the number of ways to get 4 flips, what I did was I drew out 4 little lines, and I know that for each flip there's 2 options. It's either head or tail. So that's why I put a 2 under each line. So here I noted that the number of objects per spot is n equals 2, because it's either heads or tails. And the number of spots I have is 4, which is why k equals 4. So using the formula n to the power of k, you're going to have 2 to the power of 4. And when you expand, you're going to get 16. So now that you have the components for the numerator and the denominator, you're just going to plug that in. So we have the probability of 3 tails and 4 flips equals 4, choose 3 over 16. And when you simplify that, you're going to get 4 over 16, which reduces to 0.25, which is 25%. So the probability of getting 3 tails and 4 flips is 25%. Okay, so now we're going to look at another example. It says, we have a 52 card deck. You receive 5 random cards. How many ways can you get these 5 cards? So since you're going to get 5 cards, I drew out 5 lines. And since there's 52 options, I put n equals 52 and k equals 5. Because we're having 5 spots. So we are dealing with a combination since it does not specify order. So that means our answer is just 52, choose 5. For our next example, we have 52 cards. It says, how many ways are there to get 4 of a kind plus a 5th random card? So since we need 5 cards, I drew out 5 lines again. And then since 4 of them are supposed to be the same, I underlined 4 of them in orange. And it says, so think about the types of cards we have. We have ace, king, queen, jack, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you count up all those options, it's a total of 13 options. So out of those 13 options, we need to choose 1 for the 4 of a kind. So that's 13, choose 1. Okay, so that means we'd have like 4 aces, or 4 kings, or 4 number 3s, or 4 number 4s, etc. For card number 5, so card number 5 is this card right here. Card number 5, there's 12 options, since 1 out of the 13 is being used for the 4 of a kind. Out of the 12 options, we choose 1, so that's 12, choose 1. Since the 5th card can also be one of 4 suits, which is diamond, heart, spade, or club, that means out of 4 suits, we choose 1, so that's 4 choose 1. Now we can use the multiplication rule to multiply the combinations. So we have 13 choose 1 times 12 choose 1 times 4 choose 1. Okay, so I don't need to take into account the suits for the 4 cards, because if 4 of the same card is chosen, then there will be diamond, heart, spade, and club, which is the same as 4 choose 4, which is 1. Okay? And then when you simplify out your 13 choose 1 times 12 choose 1 times 4 choose 1, you're going to get 13 times 12 times 4, which is 624. So there's 624 ways to get 4 of a kind. Just to reiterate, the previous problem was a combination problem and not permutation, because order of picking the cards does not matter. So remember that we needed 4 of a kind, and the 5th card could be any card. So I represented the 4 of a kind with orange lines and the 1 of a kind as green, right? So in this first row, you see that this is one way to get your 4 of a kind plus 1. Second row, this is another way. Third row, like this. Fourth row, like this. Fifth row, like this, okay? So in any of these options, it doesn't matter what order we pick the cards in. All that mattered was that we got 4 of a kind and then 1 other random card. Okay, so these are some important notes to note. N choose k, which we use for combination problems, is also called the binomial coefficient. And the binomial theorem from de Groot 1.8.2 is x plus y raised to the power of n equals the sum from k equals 0 to n, and then you're going to have n choose k times x raised to the power of k times y raised to the power of n minus k, for all numbers x and y and each positive integer n. The next theorem that you should know is 1.8.3. N choose 0 is equal to n choose n, which is equal to 1 for all n, and n choose k equals n choose n minus k for all n and all k, which equals 0, 1, 2, 3, all the way until you get to n.